All right, so we made it through a couple sections. Section 1.3, it feels like it's going to be a short section, but sometimes I'm a bit of a long talker, so if it doesn't turn into a short section, I mean, I apologize. But it should be short. It just has a couple of just real basic concepts, and I'll do my best to differentiate the concepts or the words or the terms in this section, because when I give tests over this material, for whatever reason, the difference between the definitions in this section are subtle, and sometimes students miss them. So kind of pay closer attention than usual when we go through this section. So this section is called subsets, and there's going to be two main terms that are definitions or words that we will define and do problems with in this section. The first term that we're going to talk about is subset, and the second term is proper subset. They're almost the same. There's just a slight difference between subsets and proper subsets that we will talk about, and hopefully I do a good enough job that you pay close attention to the difference and do well when we get to the test and the homework over this. So first word I want to talk about is subset. Subset is symbolized by kind of a U on its side with a line under it. So in this section, if I see this symbol, I'll read the word subset. If I see the U on its side without the line under it, then if I see that word, I'm going to read it as proper subset. But at first we're going to talk about subsets for a little bit. And subsets relate to sets, and they actually relate to comparing one set to another set. So a subset compares two sets. We'll say a subset compares set A and set B. And set A is a subset of B if A is essentially contained in B. And that's kind of what this says, and when I type stuff up, I try to type it in such a way that it reads kind of nicely and it's very using proper mathematics. But to say A is a subset of B, or symbolically A is a subset of B, what we're really saying is that A is contained in B. And what does it mean for a set to be contained in another set? We'll get to that next. So when I see this symbol, I think the word contained. At least that's kind of just the beginnings of what I need to think. There's some specifics that we're going to learn about here in the next couple of pages. But when I see that word symbol, I think the left set is contained in the right set, and that's a good starting point off for talking about subsets. On this page, I get a little more specific. For A to be a subset of B, so for this to be true, for this statement, for A to be a subset of B, that symbolically is A is a subset of B, we need two things to be true. First, A has to be a set. To be a subset, you have to be a set. I mean, in the definition, subset, by definition, it's a set. And for the most part, for something to be a set, it just needs to be in set braces. And then the second part of the definition, so A has to be a set to be a subset of B, and second is if any element X, if it's in A, it has to be in B. And this is really mathematically nicely written. Doesn't probably mean a lot to a lot of students, but this is saying that means that every element inside A is also an element inside B. So to be a subset, you have to be a set, and the set A, any element in set A also has to be in set B. So now we need to just kind of figure out when two sets are subsets, when one set is a subset of another one or not. And I have a few examples here before we jump into the homework. So the first example, is A a subset of B, where A equals the set A, B, C, and D, and B equals the set A and B? Well, two rules have to be true for A to be a subset of B. A has to be a set. A is written in set braces, so it's a set. So rule one of the two rules is satisfied. The second element, the second rule that we need for A to be a subset of B is every element in A also has to be in set B. More basically, A has to be contained in B. And if I look at A, element C is in A, but element C is not in B. So there's an element that's in set A that's not in set B. So A is not contained in B. It's not, inside of B. So A is not a subset of B. D is also an element that's in A that's not in B. And something set A cannot be a subset of B if there are elements in A that aren't in B. So both rules aren't satisfied, so it's not true that A is a subset of B, so we can say A is not a subset of B. The question says, is A a subset of B? And the answer to the question would be no. So the question that was posed is really a yes-no question. Is A a subset of B? Either yes, it is a subset, or no, it's not a subset. And the answer here, it's not a subset because A contains two elements that aren't in set B. Got to be a few more examples before we get into the problems. And I'm using different letters just so we can, for the names of the sets, just so we're not always using A and B. So I give you two sets in this example, set S and set T. Set S contains the numbers 1, 2, and 3, and set T contains the numbers 1, 2, 3, and 4. And it asks, yes or no, is S a subset of T? Well, for S to be a subset of T, it has to satisfy two criteria. First of all, S has to be a set. S is a set because it's in set braces. So being a set isn't really that high of a bar to climb. If you put in set braces, you're considered a set. So S is a set. That's the first criteria. Now, every element in S has to be an element of T. S has to be contained in T. And if I look at the elements of S, the first element of S is 1. It's in T, so that's good. The second element of S is 2. It's contained in T. That's okay. The third element of S is 3. It's also contained in T. That's okay. So every element of S is contained in T. There isn't an element of S that is outside of T, so S is contained in T. They're not equal to each other. S is a bigger set, but S is contained inside T, so S by definition is a subset. So when I wrote my answers, since both rules were satisfied, I can say yes, and then this comma isn't necessary, but it's kind of answering the question, putting the question inside the question. Is S a subset of T? Yes, S is a subset of T is what my answer says. All right, the next example, I switched it up a little bit. I gave you two sets, and a set S that had the elements A, B, C, and D, and the set T that had the elements A and B. And this is saying, is T a subset of S? For T to be a subset of S, two things has to happen. So for T to be a subset of S, first of all, T has to be a set, because to be a subset, you need to be a set. That's satisfied by the fact that T is put in set braces. The second thing is, the second rule that needs to be satisfied is every element that's in T also needs to be in S. And if I look at the elements of T, the first element of T is A. It's contained in set S. The second element of T is B. It's contained in set S. So every element contained in T is also contained in set S. So the second rule is satisfied. When both rules are satisfied, the answer to the question, is T a subset of S, should be yes, T is a subset of S. If you just wrote S and didn't put the T as a subset of S afterwards, completely okay. Another example. There's a few more examples that we have to do, and then we'll get into some homework. So, fourth example, is C a subset of D? Given the set C equal to set 1, 2, 3, and D equal 3, 1, 2. So again, if I look at the rules that need to be satisfied for C to be a subset of D, I need two rules to be satisfied. First is the easy one. C needs to be a set. And because the C is written in set braces, then C is a set. The second rule that needs to be satisfied is that every element in set C needs to be contained in set D. So one at a time, I'm going to look at the elements in set C and make sure that element's in set D. So first element of C is 1. I go to set D, I find a 1, so that's good. Second element of set C is a 2. I need to find a 2 in set D, and it is, so that's okay. The third element of set C is 3. I find a 3 in set D, so every element in set C is contained in set D, so both rules are satisfied, so I can say yes. And then for whatever reason, I took the time to say it's also true that D is a subset of C. If I ask this question, is D a subset of C? D is a set, and every element of D, 3, 1, and 2, is in set C. So they're subsets of each other. That's because they're equal. When sets are equal, they're subsets of each other. Okay, another example. And then we'll get to the new definition of proper subset, and then we'll do the homework. So, example, is A a subset of B? Cross this junk out on the bottom here for a second. Well, for A to be a subset of B, there's two things to check. Is A a subset of B? The first thing I need is A must be a set. Because to be a subset, A has to be a set, and if I look at A, it has the numbers 1 and 2. It's not in set braces. If it's not in set braces, A isn't defined as a set, so I'm going to say A is not a set. It's missing the set braces, so A is not a set, so I can stop right here. Once one of the two rules is violated, I can say that the set is not a subset. So A is not a subset of B, because to be a subset, you have to satisfy both rules. I'm stopping my checking once one of the rules is violated. So that's the first term. So the first term that we're working with in section 3 of chapter 1 is subset. And like I said, on the tests, students just do poorly on differentiating between subsets and proper subsets. So everything we've done so far has only focused on specifically a subset. And a subset, because it has a little bar under it, two sets can be subsets. A set can be a subset of another set if it's equal. Once I take that bar away, the symbol subset turns into proper subset, and with proper subset, equality isn't allowed. So I make a definition of proper subset, and proper subsets are defined very similarly to how subsets are defined. The symbol is similar, and the definitions are similar. So something set A is a proper subset of B, using the symbol without the or equal to if three conditions hold. A is a set, every element of A is an element of B. That's the two criteria we need it to be a subset. The third criteria says A can't equal B. So this symbol for proper subset is true if A is a subset but it's not equal. So just in case you want to see the difference on the same page, so we say A is a subset of set B, symbolized like this, if two criteria are in place. A is a set, and every element of set A is also an element of set B. So the big difference between the two definitions is that subset allows the sets to be equal. Proper subsets don't allow the sets to be equal. So the big difference between subsets with this symbol, it's okay for the sets to be equal. So that symbol, if I'm asked, is A a subset of B? If I see that symbol, the sets are allowed to be equal. If I see the symbol for the proper subset, it's not okay for the sets to be equal. If the sets are equal, and if I'm asked, is A a subset of B, I'm going to say no. So the next handful of problems or examples I'm going to do before we get to the homework is checking to see whether two sets are proper subsets of each other. And it's basically the same checks that I did for subsets, but I'm not allowing the sets to be equal. So a few examples back, when I looked at the set C and set D that were equal, I said yes, these sets, set C is a subset of set D. If the question was, is C a proper subset of D, I would have said no. So had this question, had this problem asked, is C a proper subset of D, my answer wouldn't have been yes anymore, because there's a third criteria. C has to be a set, C has to be contained in D, but C can't be equal to D, and here I would have written no for my answer. It's a subset, but it's not a proper subset. When sets are equal to each other, they're subsets of each other, but they're not proper subsets of each other. And we'll get to do plenty of examples of proper subsets before we get into the homework, hopefully, so that it's not confusing. All right, so example for proper subset. So is A a proper subset of B, where A is the set 1, 2, 3, and B is the set 1, 2, 3, and 4. So I go through my first rule. First rule is A needs to be a set. And A is a set because it's written in set notation. So that rule is satisfied. Second rule, A needs to be contained in B. That means every element of A has to be in set B. So I'll look at my elements of A. My elements of A are 1, and 1 is contained in B. 2 is contained in B, and 3 is contained in B. So A is contained in B, and the last thing that needs to be satisfied to be a proper subset is A can't equal B. And it doesn't equal B, because for two sets to be equal, they have to have exactly the same elements. B has the number 4 in it, which A doesn't. So A is a set, it's contained in B, and it doesn't equal B. So the answer to is A a subset of B is yes, A is a subset of B. I'm sorry, A is a proper subset of B. And so part of the reason why students may do poorly is because I'm doing poorly when I am using the symbols. When I see this symbol, I need to read that symbol as proper subset. And so I have to just keep hammering it in even to myself. When I see this symbol, I have to read the word to myself, proper subset. And proper subset doesn't allow the sets to be equal. When I see this symbol, I should just say the word subset. I need to be really consistent so you can be consistent. It is true that A is a subset of B, but it's also true that A is a proper subset of B. And here, I'm checking to see whether A is a proper subset of B. And I need to just really, really buckle down and not lead you down any wrong paths. So in this question, when I see that symbol as a proper subset of B, there's 3 tests that I need to do. Did all 3 tests, so when I write my answer, A is a proper subset of B. Next example, is S a proper subset of T, where S has the sets A, B, C, and D, and T has the set A and B. So for S to be a proper subset of T, 3 rules have to be satisfied. The first rule, S has to be a set. And S is a set because it's in set braces. The second rule to be a proper subset is S has to be contained in T. And this is where it breaks down. Because S has the letters C and the letters D that aren't in set T. So S is not contained in T, so it would be wrong. All the rules are not satisfied, so the answer would be no, because S is not a proper subset of T. So once a rule gets voided, once I can look at it and say this rule is not true, I don't need to check the next one. I checked rule 1, because it was good, so I went down to rule 2, and rule 2 needs containment, don't have the containment, so I'm going to say S is not a proper subset of T. Alright, so another one, is T a proper subset of S, where S is the set A, B, C, D, and T is the set A and B. 3 rules to check. Rule 1, is T a set? And again, anytime we have the set braces, we'll answer yes, it is a set. That's all you need for to be a set, is to have set braces. Rule 2 for proper subset, is T contained in S? Well, let me look at the elements of T. A is in T, A is in S, B is in T, B is in S. Every element of T is contained in S, so T is definitely contained in S. Now to be a proper subset, T can't equal S, because proper subsets aren't allowed to be equal. And T doesn't equal S because S has 2 more elements than T. So all 3 rules are satisfied. T is a set, it's contained in S, but it's not equal to S. So yes, T is a proper subset of S. T is a proper subset of S. Okay, and at any time if you're like, well, I mean, you're going to be bored when you're going through my videos. That's just the way it is. I'm completely sorry about that, but I don't, it's just the way it is, sorry. But anyways, at any point you're like, I don't need to see another example. You're doing like way too many examples. And then fast forward to the homework and see if you can do the homework. That's completely fine. You don't need to watch me do every single example if you think you understand the concept after I do a few examples, and that's completely fine. But since you can't ask questions to the video, I try to give you maybe more than you might need. All right, next example, is C a proper subset of D? So for C to be a proper subset of D, I need 3 things. 1, C needs to be a set. C is a set because it's in set braces. 2, C needs to be contained in D. So I look at the elements of C. 1 is in C, 1 is in D. 2 is in C, 2 is in D. 3 is in C, 3 is in D. So C is contained in D. Rule 3 is where I'm going to break down. C can't be equal to D. I don't know how well I'm writing this here. That's why I write sloppy, so you can't really read what I'm writing, I guess, in case I write something that's stupid. Can't pin me down on it. C is equal to D, so this rule is violated. So C is not a proper subset of B. So the answer to the question, is C a proper subset of B? The answer is no. And parenthetically after my answer, I can say C is not a proper subset of D. Got to be getting close to the end of the examples. And last example, at least for proper subsets, is A a proper subset of B, where A is 1, 2, and B is 1, 2, and 3? So for A to be a proper subset of B, I need 3 things. First, 1, A needs to be a set. When I look at A, it's not written in set braces, so it's not a set. I stop when one of the rules is violated. A is not a proper subset of B, so I answered no. Is A a proper subset of B? I'll say no. A is not a proper subset of B. I don't really know why I threw this in here, other than I just kind of felt obliged to throw it in here. And this little blurb on this page as well as the next page, it basically, when we have the empty set is a set with no elements. So this symbol right here and the set braces with nothing inside, both of these mean an empty set, a set with no elements. And it turns out that the empty set is a subset of every set, and we're going to get to that on the next page. Not a hugely important thing, but it's something that might come up a bit in the homework. And so I just said this is a fact, that the empty set is a subset of every set. So how can I show this? You know, is the empty set a subset of A for any set A? Is the empty, I got to be really careful. Is the empty set a proper subset? So I said the empty set is a proper subset of every set, and it's also a subset. So the empty set is both a proper subset and a subset of every set A. To be a subset, you only have to satisfy 2 rules. To be a proper subset, you need to satisfy a 3rd rule that you're not equal. And by default, this is true. The empty set by definition is a set. It's called empty set, so it's a set. And for rule 2 to be true is a little bit tricky. For rule 2 to be violated, there has to be something in the empty set that's not in the set that you're comparing it to. And because the empty set doesn't have anything in it, you're never going to violate this rule. Because for rule 2 to be violated, you know, rule 2 is violated when we have, you know, is the set 1, 2, 3 a subset of the set 1 and 2. For this rule to be violated, the left set has to have something that's not in the right set, and then it blows it up and tells me this is not true. And that can never be false because there's nothing inside it. Since there's nothing inside of it, you can't ever have something inside of this set that's not inside of the right set. And so by definition, the empty set can never have something in it that's in the right set because it doesn't have anything in it, so that rule will never be violated. And for rule 3, as the sets aren't equal to each other, if the set A has anything in it, it's not going to equal to a set with nothing in it. So the empty set by default is a subset of every set. And a quick example here, is C a subset of D given C is the empty, and look, I just said subset and not proper subset, and that's completely my bad. So is C a proper subset of D given C is the empty set and D is the set 3, 1, and 2? I'm just going to answer yes, because by definition the empty set is a proper subset of every set, and the empty set is a subset of every set. It's a set, it's not equal, and there isn't anything in set C that's not in set D, so by definition it's a proper subset. Finally to the homework. Alright, so I'm going to go through the first 18 problems. I'm going to do all the even problems with the hopes that you do the odd problem that kind of parallels the even problem. So on this page, as in most of the videos this semester, you'll see an even and an odd problem together. I'm going to do the even problem. You should do the odd problem. And then after you do the odd problem, you should flick back to my answers, which are always on the last page or the last couple pages of the section, and check to see if your answer is right. In this section, unlike the last section, there isn't flexibility in my answers. There's going to be kind of one answer. And the way I worded the questions here is kind of going to drive how I answer. In the examples, I said, is A an empty is A a subset of B? Answer, then I answered yes or no. And then I changed it up a little bit just because it's probably good to see things changed up a little bit, because if you pick up a different textbook or you're helping a friend with their homework, they might have an author that presents things a little bit differently. So I'm going to read my question really quick. It says answer true or false. If false, give a reason. So question 1, is A a subset of B? Given A is silver, B is a set containing gold and silver and diamond. You need to figure out whether that's true or false. And I was answering yes or no, but we're going to answer yes if it's true, false if it's no. And then if it's no, I want to say which rule is violated. So I'm going to do question 2 to model this. So is A a subset of B? Well, to be a subset of B, for A to be a subset of B in problem 2, I need two rules need to be satisfied to be a subset. First of all, A needs to be a set. I look at A and it's not written in set notation. So this rule is violated. So I could say the answer to this, is A a subset of B? I can say no, but for this problem I'm going to say it's false. So I'm going to say the answer to this, A is not a subset of B, so I'm going to say this is false because it's not a subset. And the reason I'm going to say this, the reason is A is not a set. If the answer is yes or true, I don't need to give a reason because all the reasons are satisfied. So you should do something similar for problem 1. Okay, 3 and 4 work the same way. 3 wants to know, is C not a subset, but not a proper subset, but is C a subset of D? Because that notation with the line under it only has 2 criteria. The 2 criteria for this to be true is C is a set. Because it's in set braces, it's a set. And for 2, C is contained in D. Well, the only element in C, I guess it actually is an element, silver, is contained in D, so C is contained in D. Instead of saying yes for my answer, I'm going to write true. So for the answer, I'm going to say, is C a subset of D? And I'm going to say this is a true statement. I'm not really excited about the true-false as opposed to the yes-no, but I know the book that they use on campus uses the true-false for these questions as opposed to the yes-no, so I'm using yes for true and no for false. So I'll just kind of live with it. My 5 and 6 are a little bit different. So my answer, I put them, these are on the same page together, but my answer for 6 is going to be different than your answer for 5 probably. So 6 wants to ask, is A a subset of B? And for that symbol with the line under it to be true, I need two things. A has to be a set, and A has to be contained in B. For me, A is not a set. It's contained in B, but it's not a set, so it's not a subset. So my answer for number 6 is going to be false, and I'm going to say A is not a set for my reason. When you do 5, you're going to get a different answer. It's going to be true, actually. And when the answer is true, you don't need to give a reason. Our 7s and 8s are a little bit different, but they're different the same way. So, for question 8, is A a subset of B? Need two things. A has to be a set. A is definitely a set because it's in set notation. Secondly, A has to be contained in B. And well, I look at B, and B is a set of all x sets, such as x is a vowel. So that's not written in roster form. In roster form, I know it's A, E, I, O, and U, and I don't know what to do with the sometimes Y. I'm not an English guy, but it doesn't matter whether you think B deserves Y or not. A is in set A. A is definitely a vowel, so it's in set B. So the only element in A is contained in B. Whether B has Y or not is not going to keep this from being a subset. So both rules are being satisfied, so I'm going to answer true for my answer. Your answer for 7 is not going to be true because A isn't a set. 9 and 10 are the same problem. In 9, A is defined as the empty set using that notation for the empty set. In 10, my set S that I'm comparing to T is an empty set using the 0 with a slash through it. And so for this to be S to be contained in T, I need two things, but I'm not even going to check those because by definition, the empty set is a subset of every set, so I'm not even going to do any of the checks. I'm just going to default out to the generic rule that the empty set is a subset of every set. So my answer for problem 10 is going to be true. That's what your answer to problem 9 is going to be. 11 and 12, same questions, just kind of flip-flopped a little bit. But now I have proper subset. Doesn't matter with empty sets because the empty set is both a subset and a proper subset of every set. So for number 12, is S a proper subset of T? I'm going to say this is true because the empty set is a proper subset of every set. And S is the empty set, so it's a subset of T. (13) and 14, we're into the world of proper subsets, and proper subsets don't allow equality. So for 14, is A a proper subset of B? I need three things. One, A needs to be a set. A is written in set braces, so it's a set. 2, A has to be contained in B. Well, A is in set A is in set B. To be contained means any element in A has to be in set B. B is in both A and B. C is in both A and B. D is in both A and B. So A is definitely contained in B. 3, I'm never sure how to write this, but A is not allowed to equal B. And this is where this breaks down. Proper subsets don't allow the sets to be equal, and sets A and set B are equal to each other. So my answer for question 14 is going to be false. And the reason why, I'll say the sets are equal. And the proper subset notation doesn't allow the sets to be equal. If there was a bar under there, if the question was posed like that, then you only need the top 2 to be true, and then the answer would have been true. But since it's proper subset as opposed to subset, the answer here is going to be false. 15 and 16, another proper subset. And our answers might be the same, but for different reasons. Well, no, I guess they're the same for the same reason, actually. So, for 16, is C a proper subset of D? Rule 1, C needs to be a set. C is in set braces, so it's a set. Rule 2, C has to be contained in D. First element of C is W. I scan through D, I don't see a W in D. So C is not contained in D because there's an element in C that's not in D. Once I get a violation, I can stop and say this isn't true. My answer to 16 is going to be this is a false statement. And I'll say C, the reason it's false, C is not contained in D. 2 more problems before we get to a new group of problems and a lovely new 4-page long example that's kind of insane. It's not particularly hard. I think it just kind of got ridiculous typing up the work. Oh, right. So I'm going to do 18 and you're going to do 17. Is A a proper subset of B? 1, is A a set? It's in set braces, so it's a set. 2, A is contained in B. Well, look at A. A has an E in it. B has an E in it. A has a B in it. B has a B in it. A has a C in it. B has a C in it. A has a D in it. B has a D in it. A has an A in it. B has an A in it. A is definitely contained in B. The third, A can't equal to B for proper subsets, and B has an F in it. So A doesn't equal F because B has an F that A doesn't. So that's true. So my answer to problem 18 is true that A is a proper subset of B. So I'm going to write true. All right, so the next group of problems doesn't introduce anything new, but it takes every symbol that we've had in this section plus the symbols that we got in section 1.1 for set equality and jumps them together in one huge problem that I can do real quickly, and ultimately I'll do them really quickly. Oh, it doesn't actually, it does put the equal. So if I give you 2 sets, here's set A and set B, and I ask you which of these symbols are true, or if they're all false, tell me that they're all false. And so what I'm going to do is one at a time, I'm going to check each of these 1, 2, 3, 4, 5 symbols, figure out which one is true, and for an answer to this example, I'm going to write any one that's true. The only thing that we haven't done for a while is equality. For 2 sets to be equal, they have to have exactly the same elements, but the order doesn't have to be the same. So if I look at the first statement, is set A equal to set B? A has the numbers 1, 2, and 3, and B has the numbers 1, 2, and 3. They're written in different orders, but they're exactly the same elements. For two sets to be equal, they need to have exactly the same elements. So A is definitely equal to B. So in part of my answer, I'm going to include that A is equal to B. Next symbol is a subset of B. This symbol, not the proper subset symbol, but this symbol only has two rules. The two rules are A needs to be a set and A has to be contained in B. A is a set, it's in set braces, and A is contained in B because every element of A, 1, 2, and 3 is an element of B. So A is also a subset of B. So I'm done checking the first two. On the next page, I'm going to start to check the rest of these. So the next checking is B a subset of A. Well, I should write down what these sets are again because I won't remember them. So A was the set 1, 2, and 3. B was the set 3, 2, and 1. And for B to be a subset of A, B has to be a set, and that's definitely true. It's in set notation. And B has to be contained in A, and it's okay to be equal with that symbol. So it is definitely contained in A because everything in B, 3, 2, and 1, is also in A. So this is true. So this is going to be a part of my answer. In my answer, I'm writing all the symbols that are true. So I'm going to write A is equal to B because that's a true symbol. A is a subset of B. For these sets A and B, this is a true symbol. B is a subset of A. For these sets, these are a true symbol. The last two symbols, A is a proper subset of B, and B is a proper subset of A, are not going to be included in my answer because a proper subset doesn't allow sets to be equal. So this is not true and that's not true. A is not a proper subset of B because it's equal. B is not a proper subset of A because they're equal. In proper subsets, you need all three rules as opposed to just the two rules. So my answer to this example, the true symbols were A is equal to B, A is a subset of B, and B is a subset of A. The false symbols were A is a proper subset of B, and B is a proper subset of A. They don't go in my answer if they're false. Another example. So given the sets A equal the set 1, 2, and the set B, hopefully everything showed up. I think I didn't trim anything off there. Yeah. So given the set A being the set 1, 2, and the set B being 3, 2, 1, which of these are true? First, they're not equal to each other. Why aren't they equal? Because B has the number 3 in it, A doesn't have the number 3 in it. To be equal, you have to have exactly the same elements, so A doesn't equal to B, so that's not going to be part of my answer. Second one, symbol A is a subset of B, and this only needs two criteria. For A to be a subset of B, I need two criteria. A has to be a set, it's a set, so that's good. A has to be contained in B. 1 is in A, 1 is in B, 2 is in A, 2 is in B. I satisfy the two rules, so A is definitely a subset of B. That's going to be one of the symbols that gets included in my answer. Move on to the next page and continue with these sets, comparing the other three symbols that I haven't compared yet. So I need to check A is equal to B, A is a subset of B, B is a subset of A is a proper subset of B, B is a proper subset of A. So for B to be a subset of A, B has to be contained in A, and this one's not going to be true because B contains the number 3 that A doesn't. So that's not going to be my answer. It'd be wrong to say B is a subset of A because B is not contained in A. B has a 3 in it that A doesn't. Next thing I'm checking is a proper subset of B. To be a proper subset of B, there's three things. One, A has to be a set, and it's a set because it's in the set notation. Two, A has to be contained in B, and A has the numbers 1 and 2, B has the numbers 1 and 2, A is contained in B, and to be a proper subset, A is not allowed to equal B, A doesn't equal B. So A is a proper subset of B is going to also be in my answer. So far the symbols that are going to be true, A doesn't equal B, that's not going to be true. A is a subset of B, which was true. B wasn't a subset of A. A is a proper subset of B. I have one more to check to see if B is a proper subset of A. That's going to be false. So B is not a proper subset of A, because to be a proper subset, there's the three rules. B was a set. B has to be contained in B. B wasn't contained. B has to be contained in A. B wasn't contained in A. So that rule's not true because B isn't contained in A. B is not a proper subset of A. So the only rules that were true is A is a subset of B and A is a proper subset of B. So when I go to my answer for this example, the true statements, the true symbols is A is a subset of B and A is a proper subset of B. All right, now we're into the last bit of homework for the section, and I just need to figure out which of the symbols are true, and immediately when I do these problems, I don't, I'm not going to write a reason for each one of the 5 symbols. Maybe I'll justify the ones that are true. Immediately when I look at these two sets aren't equal. So is A equal to B? A is definitely not equal to B because B and A don't have exactly the same elements. White is in A, but white's not in B, so they're not equal. The two containments, A is a subset of B and A is a proper subset of B, and need A to be contained in B, so I'm going to simultaneously check these without showing, as much detail as I did in my examples. Both of those are going to be false because for A to be contained in B, everything in A needs to be contained in B. So whether these have two of the same rules. They both need to be, A has to be sets and A has to be contained in B. In proper subset, it can't be equal. In subset, it can be equal. But this doesn't matter. A is not even contained in B, so it violates the second rule for both of those checks. I'm not going to include that in my answer. But these, I might have to consider. So for this symbol to be true, B being a subset of A, B has to be a set, and it is, and B has to be contained in A. Which it is, because red is in B, red is in A, blue is in B, blue is in A. So that's definitely a true statement. And if I add the extra, they can't be equal. So for B is a proper subset of A, you have the same first two rules. We add the third rule. They're not equal to each other, so that's also going to be true. So the answer for number 20, the true statements, the true symbols that are given is B is a subset of A and B is a proper subset of A. Those are the only ones that are true. The rest of them are false because they're not equal to each other, and A is not a subset of B and A is not a proper subset of B. All right, keep going. So you should have tried to do problem 19, and now I'm going to do 22. Immediately when they're equal, which these are equal, they both have A, B, and C, then I know I can dump out the proper subsets because the proper subsets don't allow them to be equal. So immediately in number 22, I know in my answer that these two are equal. They're equal to each other because they both have A, B, and C. Immediately when two sets are equal, I can dump out the proper subsets because the proper subsets don't allow the sets to be equal. You don't see the or equal to under there. So I won't even check the proper subsets. Both of these are not good. These don't allow the sets to be equal. And when you're doing your homework, you should probably be checking these in your head and not writing down much work at all. If you just write the answer, that's all you really needed to do. Let me show you that this is true, that A is a subset of B. There's two checks. One, A needs to be a set. A is in set braces for problem 22. So that's true. And two, A has to be contained in B. A has the letter A, which B has. A has the letter B, which B has. A has the letter C, which C has. So that's true. So A is definitely a subset of B. So that needs to be in my answer as well. And then the last check to show that is B a subset of A. And for B to be a subset of A, B has to be a set. And B's in the set braces, so it's a set. And number two, B has to be contained in A. B has A, B, and C. A has A, B, and C, and is contained in A, so that's a true statement as well. So the three symbols for this problem, problem 22, that are true are A is equal to B, A is a subset of B, and B is a subset of A. The proper subset ones won't be true because proper subsets don't let equality happen. Oh, I forgot to put my little cheat sheet between here, and these things bleed through if you don't put it on. Switch my marker to one that doesn't bleed through. All right, so 24 is the next one I'm going to attack. And these aren't equal to each other. They don't have exactly the same elements, so I'm not going to worry about that. And for me, I can see that A is not contained in B. B is contained in A. So immediately, so they're not equal to each other. I'm going to cross out that one. And A is not contained in B. And that's going to cross out those two because for both subset and proper subset, for that to be true, A has to be contained in B, and A is not contained in B. So the only ones that are going to be true are these two. B is a proper subset of A, and this one, B, is a subset of A. Both of these are going to be true. This one, for B to be a subset of A, it just needs B to be a set, and B is a set, and it has to have B being contained in A, and B is contained in A. For proper subset to be true, B can't also equal A. All three of those statements are true for proper subset. The two statements B contained in A are true, and B being a set is true for subset. So the answer for number 24, the symbols that are true are the B ones contained in A. So B is a subset of A, and B is a proper subset of A. 25 and 26. They're not equal. So if I look at 26, they're definitely not equal because my B has 3 elements, my A has 4 elements. They're definitely not equal. Now is A contained in B? So if I look at the two, A is a subset of B and A is contained in B, or a proper subset of B, these aren't going to be true because look at A has the letter G in it, B doesn't have the letter G in it. So neither of these are true. These are both false. Because for that symbol to be true, for either of those symbols to be true, A has to be contained in B, which means there can't be an element of A that's in B, not in B. But there's a G there that's in A that's not in B. So those aren't any good. And if I look at the B's being contained in A, B is a subset of A, or B is a proper subset of A, if I look at these two elements, A and B are elements of set B. They're not in set A, so both of these are false. B is not a subset of A, and it's not a proper subset of A. So all 4 of the subset symbols are false, and the equality symbol is false. Those aren't equal because they don't have the same elements. So my answer for question 26 is none of these are true. So the answer to number 26, which of these are true? None of them are true. Getting close to the end here. We've got, what, 1, 2, 3, 4 problems to do. And these get a little bit trickier because now the sets aren't defined in lovely roster form. They're defined in, set builder notation. So when I do 28, I have to figure out what set A is before I can do the tests. And so, first of all, it says set A is the set of natural numbers. Well, natural numbers, they're like 1, 2, 3, 4, 5, 6, and they go on forever. But it says and less than 5. So I'm only counting the natural numbers less than 5. So set A in problem 28, the roster form for set A are the natural numbers less than 5, which is 1, 2, 3, and 4. So when I go do my tests, these are not equal to each other because there's a 4 in set A that's not in set B. And both the ones that have A contained in B will be false, because for both of these to be true, either A being a subset of B or A being a proper subset of B, need A to be contained in B. And A is not contained in B because there's a 4 in A that's not in B. So both of these are going to be false. The two that are going to be true is B is a subset of A and B is a proper subset of A. For B to be a subset of A, B has to be a set. It's a set because it's in set braces. B has to be contained in A. B has the numbers 1, 2, and 3, and each of the numbers 1, 2, and 3 are contained in A, so B is contained in A. That would be enough for a subset, and for the proper subset to be true, B can't equal A. So the first two rules are true, so B is a subset of A. The third rule is true, so B is a proper subset of A. So my answer for 28, the symbols that are true, are the ones that have B to the left of A. That is, B is a subset of A, and B is a proper subset of A. So just a few more problems to get through. Hopefully you'll be done with your homework when you get done with the video. Okay, so 30 again gives me the set builder notation. It says X is a natural number, so natural numbers 1, 2, 3, 4, 5, 6, 7, ... and X is greater than or equal to 5. So I'm counting the natural numbers that are 5 or bigger. So set A in problem 30 contains the numbers 5, 6, 7, 8, ... And when I look at this, the sets aren't equal because A has the number 5, B has the number 4, A doesn't have the number 4, so they're not equal to each other. For containment, B is not contained in A because B has a 4 in it that A doesn't. So both the B contained symbols are going to be false. So this symbol, B is a proper subset of A, and B is a subset of A, are both going to be false. These are false because for these to be true, B has to be contained in A, and B has the number 4 in it, which A doesn't. It's the A's contained in B which are going to be true. Both A contained as a subset of B and A as a proper set of B are going to be true. Because for these to be true, for the subset to be true, you need A as a set, which it is. You need A as contained in B, and A is this portion of B, so it's contained in B. So subset is true. Proper subset is also true because A doesn't equal B. So for number 30, my answer, the one symbols that are true, is going to be that A is a subset of B and A is a proper subset of B. And I might have written off just a little bit, so somewhere down here I wrote the rules. A is a set, A is contained in B, that makes it a subset. Adding the third rule that they're not equal makes it also a proper subset. So A is both a subset of B, the symbol with the line under it, and A is a proper subset of B, the symbol without the line under it. Two more. Okay, so 32 is what I'll attack next, and 32 says X is a natural number, meaning it's like 1, 2, 3, 4, 5, 6, and x is between 0 and 5, not including the 5, not including the 0. So the numbers that are between, natural numbers that are between 0 and 5, not including the 0 and the 5, are 1, 2, 3, and 4. So A are the natural numbers that are bigger than 0 and less than 5, and the natural numbers that are bigger than 0 and less than 5 are the numbers 1, 2, 3, and 4. These two sets are equal to each other, so any of the ones that have equality are going to work. A is equal to B, and for these to be true, well, equal is okay. I'm not going to go through all rules. I'm kind of wearing out. I imagine you're wearing out too. So these, all three are going to be true. These won't be true because these don't allow the sets to be equal. But the other true ones that I circle will be okay because each set is contained in each other when they're equal to each other. So my answer for 32 A equal to B is true, A is a subset of B is true, B is a subset of A is true. The ones that aren't true are the proper subsets because the proper subsets don't allow equality. All right, last problem for the day. This is the same definition. So set A, the natural numbers between 0 and 5, not including the 0 and not including the 5, is the set 1, 2, 3, and 4. So if I look at these two sets, they're not equal to each other. B has the number 0 in it, which A doesn't, so they're not equal. And A is contained in B, because this portion right here makes A. So A is definitely contained in B, but B is not contained in A. So if I do these one at a time, is A a subset of B? To be a subset of B, A has to be a set, which it is, and A has to be contained in B. A has the numbers 1, 2, 3, and 4. B has the numbers 1, 2, 3, and 4. So this one is true, that A is a subset of B. And is A a proper subset of B? You have the same first two rules, that A is a set, A is contained in B. The third rule, A is not equal to B. A isn't equal to B, so A is also a proper subset of B, so that's going to be true. The ones that aren't going to be true are B is not contained in A, because B has the number 0 and A doesn't have the number 0. So both the ones that have B contained in A won't be true because B isn't contained in A. It's not a proper subset of A, and B isn't a subset of A. So my answer to the last problem in this section for number 34, the state symbols that are true is that A is a subset of B and A is a proper subset of B. All right, so hopefully you're done with the homework and you're feeling good about the section. Take a break if you want and maybe hit the next section if you're feeling motivated, or just put it away and be done with math for a little bit. Thanks.